Good morning, good afternoon, and good evening, and welcome to our June 2023 Coffee Corner for STAAD.Pro. I'll go ahead and introduce myself. My name is Sabrina Tedeschi, and I'm going to be your presenter today. Now, that being said, let's go ahead and discuss our topic today. And this is my official welcome to our Coffee Corner. This is June 2023. And what we're going to be showing you today is how to design truss connections in STAAD.Pro with RAM connection. Now, RAM connection is a design program that you can use to rapidly design, optimize, or verify steel connections according to a variety of US and international design codes. RAM connection could be used as a standalone solution or in conjunction with an analyzed STAAD.Pro, RAM structural system, or RAM elements model. Now, for this session today, we're going to be focusing on using the RAM connection mode within STAAD.Pro to specifically design some truss connections according to the AISC 36016 specification. Now, before we get started, let's first discuss some of the key features of RAM connection for those of you who may not be as familiar with this product. Now, RAM connection can design steel connections for a variety of different joint configurations. And again, it works as a standalone application or in conjunction with another one of our analysis programs, including STAAD.Pro. So those joint configurations would include beam to support joints, beam splices and column splices. We can design base plates and column cap plates, as well as vertical and horizontal gusset connections. Now, in addition to that, RAM connection can design tubular truss connections and gusset truss connections. And this is what we're going to be focusing our attention on today, is designing these specific types of connections for a model that's been created and analyzed in STAAD.Pro. So let's discuss our agenda or our goals for today's session. We're going to basically split this into two parts. The first part would be going over some modeling steps for the design of truss connections in STAAD.Pro. There's a few things I always like to point out to users whenever you're taking a look at a particular workflow, things that you want to be aware of. So when we're talking about truss connections in STAAD.Pro, a couple areas I want you to focus on would be ensuring that your section and material properties are set appropriately, as those will be available in RAM connection. Make sure you enter your member specifications appropriately for the assumptions that are used in a truss connection. And make sure you set up your member attributes. We're going to be walking through a model that's already had all this stuff defined for it, but I want you to be aware of it and know how to do it yourself. In addition to that, the second part of our session will be focusing on actually designing the truss connections in the RAM connection mode. And we do have two different types of truss connections available. We have a tubular truss connection and also a gusset truss connection. So let's go ahead and turn our attention to our STAAD.Pro start screen. And whenever I'm discussing RAM connection, I like to start here. I like to start with a model that hasn't already been opened yet, because it is important to understand the license configuration within STAAD.Pro if you're planning on using RAM connection. So full use of the RAM connection design mode in STAAD.Pro would require a valid RAM connection license. The RAM connection mode will run with a limited set of steel design connections available with only the standard STAAD.Pro license. If we take a look in the bottom right-hand corner of my screen, I can see that the RAM connection license is currently active, which again will open up the full access of this program. And this would be necessary for designing truss connections in RAM connection within STAAD.Pro. Now, if you don't have access to this license, I would encourage you to go ahead and talk to your account administrator here at Bentley And if you have access to this license but don't have it turned on, what you can do is go to this license area and you can select your appropriate licenses that you'll be needing for that session. Here you can see my RAM connection is already selected. So that is step number one. You want to make sure that your RAM connection license is selected. Now let's go ahead and open up the sample model that I will be using in this session today. Okay, so I have a basic truss style structure. I'm going to go ahead and call it a warehouse for the purposes of today's session. I do have quite a bit of repeated geometry through this, but I do have enough geometry in it to show you the full types of connections that we have available for truss connections within STAAD.Pro and RAM connection. Okay, let's go ahead and review this sample model and take a look at some of those key areas that I want you to be aware of whenever you are preparing on using RAM connections to design your truss connections in STAAD.Pro. The first area that I'm going to go ahead and take a look at is the properties area. There we go. Is the properties area. Now it's important to understand that the connection design mode in STAAD.Pro is used to dynamically link structural model data, including your section properties and analysis results, to the RAM connection application to check connection designs for code compliance. Okay, so that being said, you're going to specify, of course, your section properties within your analytical modeling mode or physical modeling mode if that's the workflow that you prefer. RAM connection can work with either one to set up your section properties. Now here we're going to see, and I'll go ahead and highlight the assigned geometry, that I have some columns in my model. Those are wide flange sections. I have several different types of square and rectangular tube sections within this model. I have some round HSS pipe sections, and I also have some steel rods, channels, and some of my branches or core members are wide flange sections. Now, why is it important to go over this? Well, first of all, it's important to understand that RAM connection will be grabbing your section properties from this STAAD.Pro analysis in order to design the connections. It's also important to understand because basically the types of sections you have is going to dictate the type of truss connection that you're going to be able to design. Okay, so as I mentioned earlier, we have two different types of truss connections available in RAM connection. We have a tubular truss connection, and we also have a truss gusset connection. So kind of understanding what section properties you have will gear you towards one type of truss connection versus another. Okay, and it's important to know that their detailing might be slightly different, and also the code sections that we're going to be using will be slightly different depending upon if you're using hollow structural sections versus if you're using maybe non-hollow structural sections or additional section types. Okay, so for a tubular truss connection, we would call this a CHB in RAM connection. Okay, when you're designing this, basically it means that your chord members, your top chord, bottom chord, along with your branch sections will be all hollow structural sections. They can be rectangular, square, or circular sections, and it is important to note that the branch sections should all be of the same shape. Okay, so if all of your branches are all round or all of them are all square or rectangular, that's what we're looking for a tubular truss connection. When we select the AISC 36016 specification, when we select this type of connection, we will be looking at Chapter K. This is the additional requirements for the HSS and box section connections from the specification. In addition to that, we will also be using the AISC Steel Design Guide number 24, Chapter 8. This is for hollow structural sections for basically HSS truss style connections. Okay. In addition to that, if you have a truss that doesn't fit those criteria, you can still assign a truss connection, but you're going to go with a truss gusset connection. This in RAM connection we would call a TGB connection. Here we have a lot more freedom about which type of shapes we could use for the chords and the branch sections. When we select this type of connection, the program will go ahead and use the AISC 36016 Chapter J, which is just the basic design of connections portion of the specification. Now, our model contains several types of joints where a tubular truss connection would be allowed and appropriate. For any of my other truss connections, I'm going to go ahead and go with a truss gusset connection. So if I don't fit that criteria for a tubular truss connection, I'll go ahead and select the other type. So it's important to understand how your section properties can dictate what types of connections would be available to you. Let's go ahead and now take a look at our material properties. So let's do that here. So I'm going to go ahead and select the materials. I know my screen looks very busy, but let's go ahead and scroll on down and see the types of materials that I assigned. For this particular model, I went ahead and assigned several different material properties which are providing the appropriate yield strength for the shape that they are according to the US standards. Okay, so here you can see my steel rods. I went ahead and defined them as steel. I called it 36 KSI. And what I do whenever I'm using RAM connection is I will go ahead and create several different steel material property types to go ahead and satisfy my needs within RAM connection. So let's go ahead and click on one of these and tell you what I mean by that. What's very important is that when you are designing your connections, that the RAM connection is using the appropriate yield strength of steel. Now, RAM connection uses the yield strength of steel as defined in your material property. So you don't want to assign everything in your model the generic steel material property if that yield strength of steel wouldn't be appropriate for that particular member. Okay, so for my particular model, I went ahead and created my own material properties. Here I have one for 36 KSI. I have one for 50 KSI. My model also contains some HSS rectangular and HSS round shapes. So I went ahead and was very particular in assigning which materials are appropriate for which members. And of course, this means that the appropriate yield strength of steel will be used in the RAM connection design. Now, that's very important to understand that that's where this information is coming from. Typically, when I would design a steel structure in STAAD.Pro, I would define the yield strength of steel using a design parameter. The RAM connection mode uses your material properties and not any of your design properties. So it's important to note that your material properties are assigned appropriately. Now, I can see that information here, and I can also double check it in the properties table. And you can see here all the different material properties that were assigned to this particular model. Let's go ahead and proceed on and take a look at our specifications. Okay, and we'll go ahead and highlight our assigned geometry again, and we can see that I've gone ahead and assigned some member truss and member tension specifications. Now, it's important to understand that all branch members in your truss joints must be assigned as either truss members, tension only, or compression only members. Now, this means that the analysis will consider this member capable of resisting axial loads only, which corresponds to the RAM connection design requirements for truss connections. Okay, so you can see for most of my branch members, I went ahead and assigned them as truss members. These branch members, just in case you're curious, happen to be, I have some channels in here, I have some round HSS sections, I have some square or rectangular HSS sections as well. I also made the decision that I felt that my steel rods would be capable of resisting tension loads only. Okay. Now, the last thing we're going to take a look at, which is maybe part of a workflow that you might not be as familiar with, is to make sure that your member type attributes have been assigned for truss connections. So for truss connections in STAAD.Pro, RAM connection will need the chord and branch members identified through the use of a member type attribute. Let me go ahead and show you how to do that. So for this particular model, I went ahead and set up some groups to make the selection process easier. So let's go ahead and select some of my groups, and let's go ahead and select, you can see I called my main trusses, and the ones on the side I called side trusses. So here you can see my side chords and my main chords. Now what you're going to do when you're ready to assign this member type attribute is you're going to go ahead and select the appropriate members, either chords or branches. Okay, you're going to go to your beam tools, and you're going to go ahead and say add attribute. Okay, whenever we're talking about RAM connection, we're going to go to the member type, and you can see I have two different types here. I have branch and chord. These are the two that are appropriate for truss connections. And for a truss connection to be assigned in the RAM connection mode, you would need to clearly define which is the chords and which are the branches. So here, if I was going to go with the chords, I have the chords selected. I would just go ahead and say apply. If I wanted to do the branches, and again, I love using groups for this sort of thing, I'm going to go ahead and say add attribute, member type, and we're going to call that a branch. Okay. Any member that wasn't assigned the branch or chord is not eligible for a truss connection. So that's going to be very important. Now, after you go ahead and assign your chord and branches, you can go ahead and see that information in the input file, which is where I would usually go if I were to make a modification to any of that after the fact. So let's go ahead and see where that is in the command file, just so you're aware. And let's see. I'm going to just go ahead and scroll on down until I find it. Would probably be easiest for me. Oh, here it is. Define member attribute. Okay, you can see here that it went ahead and said member type chord. Those are all my chord sections. Member type branch. Those are all my branch sections. If you were to copy and paste this into the select by list command, we should be able to display which ones are assigned as a chord and which ones are assigned as a branch. So that information can be defined through the graphical user interface, through the beam process, so the beam parameters. So here again, you'd select a member, go to beam tools, add attribute. If you wanted to see which members were assigned that attribute already, you can go ahead and take a look at that in the input file. Now at this point, we are ready to move over to the RAM connection mode. And the RAM connection mode, we're of course going to need our model to be analyzed. So let's go ahead and run a quick analysis. After the analysis is complete, I go ahead and take a look in this dialog to see if I have any errors or warnings. Now, I'm assuming I've already looked through the post processor. I'm assuming I've already checked to make sure all of my members are passing the relevant code checks before I move on to the connection portion of my workflow. But let's go ahead and fast forward through that process and go to the connection design workflow, because I've already done those steps before this session. So to access RAM connection, you're going to go to your workflow panel on the left-hand side of your screen and find connection design. When entering RAM connection, you're going to be given a validation report. Basically, what this is going to do is it's going to grab those material properties from the materials table within your STAAD.Pro model and bring them over to RAM connection. I like that this dialog pops up because what it does for me is it reminds me that those material properties will be very important for my connection design, and it reminds me to make sure I've specified them correctly. Now I took the time to specify those correctly, so I'm going to go ahead and click close and understand that those were brought over from my STAAD.Pro application. Now, once you're in RAM connections, it's important to note that connections will be designed in this mode by basically creating joints from the geometry and section properties. Forces resulting from the analysis are used in this mode by assigning a load envelope, and then a set of connection templates can then be assigned to a join. Now, before I ever start any connection design workflow, I like to review the loads and information or settings within RAM connection. To do that, we're going to go into the RAM connection input dialog, and let's go ahead and select this first icon. This is your load envelope icon. This will dictate which load cases or load combinations will be used in your connection design. For me, for my model, I'm going to go ahead and grab my load combinations only. And I went ahead and generated load combinations in the main application that would be suitable for the RAM connection mode or for my connection design process. Let's go ahead and click OK. In addition to that, I do like to review some of my settings. Now, the load combinations that I generated for this particular model are LRFD style load combinations, and I am going to be designing my connections according to the AISC 360. I do want to make sure that I select the appropriate design code when starting RAM connection. Now, in addition to that, RAM connection can design connections according to the AISC 34105 and the AISC 358 seismic provisions. Now, these would be specific for lateral types of connections, which don't include our truss connections. So I'll go ahead and leave that option unselected. Lastly, we have this option here, design multiple selected connections individually or grouped. Okay, so grouped would be if you have this unselected. Now, when you design connections within RAM connections, you can select multiple joints at one time to basically be designed together. Now, for my particular model, since I do have quite a bit of repeated geometry, I'm going to go ahead and make the decision that I'd like you to design them in groups. Now, does that mean every single joint that you have selected will have the identical connection? No, because I do have different situations. I have different styles of joints for my trusses, but it will say, well, if this joint is geometrically identical to this one, I'm going to try to assign the same connection details to both, which will make for my particular structure fabrication a little bit easier. Okay, so let's go ahead and click OK here. The last thing I'm going to take a look at are the material properties. Now, as I've mentioned a few times, we're going to go ahead and bring those material properties over from your STAAD.Pro application. Here I can see all of the steel material properties that were defined in the STAAD.Pro model are available in RAM connection. And this is a great place to just double check what yield strength of steel will be used for each of those steel material properties. Okay, so that was pulled over from the analysis. Now at this point, we are ready to start assigning truss connections to our model. Okay, so that process starts with making the selection. Which members or which joints do you want to assign this connection to? And I'm going to start with my tubular truss connections. Okay, so those would be, I'm going to go ahead and call those my main trusses, the ones that are going parallel to the global x-axis for this particular model. Okay. Now, as I mentioned earlier, I really like selecting things by groups, and I went ahead and created some groups for this model to make the selection process easier for myself. So what I'm going to want to do when I'm ready to assign a connection is I'm going to want to select the branches and chords for each of the joints that I'm interested in designing in that particular step. And for me, I'm going to go ahead and select the main chords and the main branches. So here's my main trusses. And what I'm going to do is I'm going to attempt to assign a tubular truss style connection to the currently selected joints. Okay. Let's go to the connection design tab in the ribbon toolbar. And I have these two major options, basic connections or smart connections. Okay. A basic connection template, let's go ahead and hover my cursor there, contains all of the information about the connection, such as the plate sizes and bolt locations, which are applied to the joint and then checked as code compliant. What you would do in a basic connection workflow is you'd select a series or a group of connections that you want to be used as candidates for the currently selected joints. For each joint, it's going to start at the top of the list and work its way down until it finds one that passes the code checks, and then it will select that template. I call this more of the trial and error approach, where we're using very specific templates as candidates for your connection design. In addition to that, we also have our smart connection workflow. Now, a smart connection template contains parametric rules defined in a macro, which allows characteristics of the connection to be modified within limits to achieve code compliance. A joint selection set that is used for a smart connection design would typically include one template, not a group of templates. Now, when you're designing any type of Truss connections, these are only available as smart connections because we need that macro in order to kind of evaluate the connection joint and to make the adjustments as needed. So when you're ready to assign your Truss connection, we can go to the Smart Connection Workflow area. All of the information at the top of this dialog was specified in the Settings area. I can review that information if I want to, but this is all automatically taken from that Settings icon, which is this one that looks like a gear. Okay. Within this dialog, though, I do need to tell the program which type of connection I'm designing right now. And you're going to want to make sure that the joints you currently have selected are compatible with the connection template that you're selecting. So here I'm going to go ahead and scroll on down, and I'm going to find my two types of truss connections. And I'm going to go with a cord branch connection. This is that welded tubular truss connection. I'm going to select the Smart Connection template and move it over to the right side, and then we'll go ahead and click OK. And the connection process has now been kicked off. Okay, and it's complete. Let's go ahead and take a look at this validation dialog. Now, this validation dialog, I like to tell everybody, don't just close this when it pops up on screen, because this contains a lot of really good information about how successful your connection process was. So I like to go ahead and scroll on down in this dialog, and I'm going to see for each joint that it found during that process, it's going to let you know if it was okay. Okay, so okay means it basically was able to design a connection for that joint. No warnings or errors were produced. It's going to let you know if you had a warning. Basically, a warning would mean that, well, we found something that was code compliant, but maybe some of the geometric considerations that the code is recommending were not fulfilled for that particular joint. So we're going to go ahead and flag those for you. And the last thing you're going to see is you're going to see this issue. Cannot be designed due to the following error. This is what I especially look for in this dialog, because there are times where I select certain members and it's not compatible with the connection template that I selected. Okay, and here we're going to go ahead and list some of those common reasons. So branch does not comply with one or more of the following. The branch section must be tubular. Well, I'm satisfying that, so that one should be good. Cord section should be wider than the branch section. I actually know I followed that as well. But then I have this last one. Branch sections should have the same shape. Well, I have a couple of trusses where some of the branch sections are round, some of the branch sections are rectangular. And what this note tells me is that those joints were not assigned. Okay, so I'm going to remember that and say, well, this one didn't work for those particular joints. I'm going to go ahead and assign a truss gusset connection to those instead. Okay, so it goes through and made its attempts, and I have all of this information. Okay, now at this point, I know that a good portion of them turned out okay. I have some with warnings, and I have some that weren't designed at all. So let's go ahead and click close. Okay, I'll go ahead and close that area as well. Now, how do I know which ones were designed and which ones weren't? Okay, anywhere I see this little gray triangle, that means a connection was assigned there. Okay, anywhere where I don't, means it wasn't. Okay, so I know here, here, and here for each of the trusses were not assigned a connection. So I'm going to remember that and come back to those in a little bit. Okay. In addition to that, anything that was assigned a connection, so this would be anything that said okay, anything that had a warning, will go ahead and give me its information in the RAM connection input area. Okay. Anything in green means that that had a status of okay. Everything worked out fine. We found a connection that was code compliant that did not produce any warnings. Any field that is yellow means that we did find a connection that passed all code checks, but we're going to produce a warning because something in the code that is recommended you did not follow. Okay, so we have yellow and green over here. Now, if a connection was assigned but didn't satisfy all your code requirements, meaning its interaction ratio was greater than 1.0, you're going to go ahead and see that here as well, and we'd have that third color, the red color, which again, we'd want to go ahead and adjust before finishing up. Now, one of the things I like to point to is because on this page, we see everything as color-coded. Okay, but there are a lot of people that might not see colors or the difference between green and yellow. So what I like to do is I like to go to this results area, and if you like to see your information this way, this is a great place to go, because what this will do for you, let's go ahead and bring this on over. It's going to go ahead and give you that status. Okay, so anything that was yellow, it's going to go ahead and say warning. Anything that was okay is going to tell you okay. So if you like seeing the status words instead of just color coding, this is a great place to go. Let's go back to this connections area. Now what I'm going to do is I'm going to take a look at some of the connections that produced warnings for those tubular truss style connections. And what I'm noticing for my particular model is that I have several connections that are probably identical because I have a lot of repeated geometry, which I would say would be fairly typical for a warehouse type structure, which I'm designing. Okay, so what I want to do is I want to edit these connections. So typically whenever I get a warning or an error, my first place I go is the connection pad. That will reveal all of the connection design parameters. I can review the results file, the equations, and the DXF model. But for a repeated structure like this, I may want to review that information for a bunch of connections at one time. So what I'm going to do is I'm going to go ahead and select through this table one of the connections that produced a warning. Okay, I'm going to go ahead and select this one. Then what I'm going to do is I'm going to make sure that this is my active window, and I can go to this select connections option, and I can tell the program I want to select all connections that are identical to the one I already highlighted. So I'm going to say select identical connections, and we'll see that RAM connection automatically selected all connections that were identical to the one I already had selected, because I'd like to not have to change all of them individually. I'd like to change them together because I know that they're identical. Okay, so I have them selected, and I can go ahead and click on the edit button. So here is my tubular truss connection. This would be a fully welded connection. Now I do like to remind you, for a tubular truss connection, we're going to use, since I selected the AISC 36016, we're going to use Chapter K. That would be additional requirements for HSS and box section connections, and it uses this along with the AISC Steel Design Guide 24. That's the design guide for hollow structural section connections. Okay. Now here again, I can see my color coding and my interaction ratio, and it's in yellow, which does mean that I received a warning. So let's go ahead and review that information, and we're going to go to this results area. This will bring up the steel connection report. Now the steel connection report might be longer depending upon how many connections you have selected at one time. The reason for that is because it will report the loads on each individual connection that's in your selection. Oh, apologize for that. My report showed up on my other screen. So this is a slightly longer report than if you had just selected one member at a time. But basically what it's going to do is it's going to grab all of the loads on every single joint that you currently have selected. And I can go ahead and scroll on down. Okay, let's see if I can do this slightly faster. There we go. There it is. Okay, so what we're going to be able to see for the joints is you're going to be able to see your geometric considerations and your design check information. Now I mentioned earlier that we're going to use Chapter K of the AISC 360 for tubular truss connections, and you're going to be able to see all of your code references available here. Now, if you would like some additional information regarding the equations, you can go ahead and click on this icon here. This will show your formulas. So this will be able to show all the formulas we use to arrive at these results. We're going to indicate code sections. You'll be able to see all the variables that were used for each of those equations. Now, I'm not going to go ahead and click on that button right now because it may, in this live session, take a little while to generate that report. But do know that that is available because that's a very helpful place to go when reviewing your report information. Now, so far, I'm not seeing anything that produced a warning, but I'm going to go ahead and scroll on down a little further. And I found it. Okay, so geometric considerations. We're going to see that I have an overlapping percentage. Now, what we're going to do whenever we have a geometric consideration is we're going to show you the minimum and maximum recommended value and the value that we used for your particular model. So here I can see that the overlap percentage, and this is the table we're looking at, okay, is not quite as recommended. Okay, now I have more information and I know what I can do to adjust this connection to get to a passing connection design without warnings. So let's go ahead and close out of this report. And let me point out a few of the parameters that you can go ahead and adjust for your connection design. The first one is in this members area. Here we have the bottom branch placement order. We have overlapped by branches as an option and overlapping branches. And then you can enter an eccentricity. Now, with this type of information, I kind of like to review this on the DXF view. So if I went to the DXF view, I'd be able to see how it was going to be detailed now, where exactly that working point is going to be, whether or not I'm overlapping my branches or overlapped by branches, and I can go ahead and adjust this. And what I'm looking for is I'm looking for this to turn green. So let's go ahead and modify some of the information. And here what I've done is I've gone ahead and modified that bottom eccentricity. My interaction ratio is now green and it's not producing any more warnings. It's still passing the code check. Now, since I have several different joints selected at one time, this would be the interaction ratio at the worst case joint that I've selected. So I know all of them, none of them produced a warning, and I know all of them, the highest interaction ratio that they're yielding is 0.41. Well less than 1.0, okay? So here I'm feeling comfortable with my connection design. And again, I keep modifying these parameters until I get something that works for code requirements, recommendations, and also the way I would like to detail it. In addition to that, you do have the option to add reinforcement plates. So this I might go to if I were in a situation where I had an error on a connection design. Basically, I couldn't find a connection design that worked. So for reinforcement plates, we can go ahead and add one to the flange. That would be basically where it's being welded, or on the side, basically a side plate here. And then once you select those options, you'd be able to customize them. Now for this particular model, I'm going to go ahead and say that I like the detailing that it's come up with. I'm going to save the changes and then exit out of the connection pad. Let's go ahead and give it a moment. And I went ahead and updated all that information. Let's go ahead and click off that area. Now we can see that everything has been turned to green, okay? Because I modified a bunch of those joints at the same time because they were identical. Now it is important to note that you wouldn't be able to edit several connections at one time if they weren't identical. So the best way to do that is to ask the program to just go ahead and select identical connections, okay? Now, let's go ahead and work on our side trusses, okay? Now the side trusses have non-HSS sections in them. You know, my chord sections are wide flange, some of my branches are channels, some of my branches are steel rods. So I know what that does for me is it basically pushes me into an area where they're still acting like a truss, but I need to go ahead and assign a gusset truss connection to those joints. So let's go ahead and make that selection. I'm going to select my chords and my branch members through my groups that I already created. I'm going to go to the connection design area and I'm going to go ahead and say assign a smart connection. This time, I'm going to go ahead and scroll on down and say I want a truss gusset connection. I'm going to select the Smart Connection template and then click OK. And then I'm going to allow the program to run through the process. You can see here 44 joints are being designed right now. Whenever you are designing joints, it's automatically going to be added to the RAM connection input dialog. And again, I'd like to scroll down here to see if I have any errors or warnings. And good news, everything turned out okay. So let's go ahead and close out of that area. Now, in case you were curious, we can go ahead and select any of these joints. Let's go ahead and select, that's a tubular one. Let's scroll on down and select one of those gusset ones. Let's select this one, for example. Let's go ahead and double click on that one. Double click will allow you to edit one at a time. Okay, and then we can see the options that we can affect for that gusset truss connection. Okay, so let's go ahead and scroll on down. Now, again, it is important to note that we can access the report for any of your gusset truss connections. And since we are using a truss gusset connection, the program is going to design your connections according to Chapter J of the AISC 36016 specifications. We're going to see those appropriate code sections and tables listed in your report. So here we can go ahead and see that all the geometric considerations were satisfied. This is why we did not produce any warnings for this particular connection. We can see the design checks that were performed, and we can go ahead and scroll on down and review all the checks that were performed for the currently selected joint. Here I can see that the ratio is the global critical strength ratio is less than 1.0, and I didn't see any warnings in that report, and it is in green, meaning that we have satisfied all our recommendations and code requirements. Now, in addition to that, when you're working on a truss gusset connection, you can go ahead and edit the connection within the connection pad if there's specific pieces of information you would like to go ahead and customize or have control over. And if you've ever used RAM connection within STAAD.Pro, this would be very similar to editing any type of gusset connection, whether it be for a vertical braced frame or a horizontal braced frame. Okay. The way we specify the different pieces of information for a gusset connection is based on their interface. So here we can see I have an upper gusset because it's on top of the cord member. So you can see this was a bottom cord and we have a gusset on top of that. That's an upper gusset. I can go ahead and customize the material properties or thickness of that gusset plate. If I wanted to control the connection between any of the branch members and that gusset, I'm going to go ahead and select any of these upper options. So I have an upper right branch, that would be one of my rods, upper left branch, that would be one of the other rods, and then just plain upper branch, that's going to be your vertical member. Okay, so here we can see, let's go with upper branch option. Here you can see we have the option to go with either a bolted or welded connection, and then we have several different options available in addition to that. Those same kind of pieces of information can be controlled for the upper right and upper left branches if they exist in the joints that you selected. Now the last thing I'm going to do, let's go ahead and take a look at that DXF view. Everything looks good for me. Since I had a passing connection design, I'm going to go ahead and keep the default information that was determined during the connection design process for this joint. Now the last thing we're going to do, I can go ahead and close on out of there, is take a look at those main trusses, because when we designed the tubular truss connections for those main trusses, we did get that warning. And what the program is looking for, what the code is asking for, is that all your branch sections are the same shape. And I have a couple of joints where I have round and square or rectangular hollow structural sections coming into the same joint. Okay, so we were not able to satisfy the criteria for assigning a tubular truss connection there. And instead what we're going to go with is a gusset truss connection. So as I mentioned earlier, the importance is to understand how to read your graphical user interface for RAM connection. And I can see this little gray triangle at every joint that was successfully designed. And any joint that wasn't designed is missing that. Okay, so what I want to do is I want to select all the members that exist in that particular joint. I can do them one at a time by doing this, just using my beans cursor, selecting those members. That would be my requirement for assigning a gusset truss connection there. Since I have very repetitive geometry, I might also be able to view another perspective. Okay, this is a very easy way to see that, yeah, I have some joints that weren't assigned. Okay, so here I can hold down my control key. I can select these members. I can select these members. Didn't get them all. There we go. I want to select this vertical and then this portion of the top chord. Did I get the vertical? No. There we go. Okay. Basically, I'm assigning a connection here. Okay. I'm assigning a connection here. And I'm assigning a connection here. Since my geometry is repetitive, by taking a look at an elevation, I can select them all at the same time. Okay. Now we're ready. Let's go ahead and go with our last truss connections on this job. I'm going to go with a smart connection workflow. I'm going to go ahead and say this is going to be a truss gusset connection, and I'm going to grab the truss gusset template and click OK. And I'm going to allow RAM connection to run through. Now, it might say that you have more joints selected than you really think you do. That's because anytime it finds any two members coming to an intersection, it thinks that that's a joint. So what I'm going to do is I'm going to wait for some dialogues to appear on my screen asking me if I want to replace any of the currently assigned connections. And if I get that message for this application, I'm going to go ahead and say no. I don't want to override the tubular truss connections that you already assigned. I just want to focus on the ones that don't have a connection already. So let's go ahead and let it finish its process. There we go. Do I want to replace a connection? No. Okay, again, anytime I have two members coming together, including like say, see where my cursor is here? It's going to think that that's a joint I want to assign a connection to at this point. And I don't want to do each joint individually. So I went ahead and made that selection, and I know that I'm going to get this dialog. I'm just going to say no. So I don't want to replace that connection. It's going to pop up for each one it finds. So I'll go ahead and quickly get through these dialogues, and then we'll take a look at our results and detailing. Okay, it has completed its process. I'm going to go ahead and scroll on down. Okay, here what we have is we have our statuses being reported. Now several of these say okay. Again, we've learned already that that means that a acceptable connection design was found and no errors or warnings were reported. I do have a couple that says no good. Okay, that says no good. So for anything that says no good, it basically means that this failed the code check. Okay, we attempted to assign a connection to that joint. We did assign a connection to that joint, but your interaction ratio is greater than 1.0, which means it's currently failing. Okay, this means this is the type of joint that you're going to want to spend a little extra time on in the connection pad. Maybe play around with some of those connection interfaces, add reinforcing if necessary. So here we're going to go ahead and see no good in several different areas, and we'll go ahead and click close. Let's scroll on down in this dialog. All new connections have been added here, and exactly what I just mentioned earlier, we have several truss style connections that yielded an interaction ratio greater than 1.0, which means they're currently failing. I should definitely go ahead and take a second look at this, maybe adjust the welding, maybe adjust the bolting, maybe I need to adjust the model itself, okay? So that is what I'm going to want to do. And just like I had in the previous exercise, if I have connections that are geometrically identical, I can go ahead and edit them together. Now for this session today, because we are kind of running low on time, I won't go ahead and get this to a fully passing connection. I think what's important to understand is, first of all, what's important for your model when preparing a STAAD.Pro model for the RAM connection workflow. Section properties, material properties, specifications, and attributes are going to be very important, and that sort of information is going to be brought over to RAM connection. It's also important to understand which code sections will be used for either gusset truss connections or also tubular truss connections, which are both available through the Smart Connection workflow. Connection templates can be edited together, and the status of all of them will be indicated in your RAM connection input dialog. And again, if we go to that results area, we'll be able to see a bird's eye view of the status of each of the joints that were designed thus far. Now, this workflow is meant to be a workflow that will allow you to make changes to your model as you go through your typical workflow. So say I save my model at this point and I come back to it another day and it turns out that maybe some of my section properties need to change, okay? Or maybe the loading on my roof structure has changed. What you're going to do in that scenario is you're going to go back to the analytical modeling mode in STAAD.Pro, make your appropriate changes, reanalyze your model, and come back to RAM connection. Every time a new analysis is available from STAAD.Pro and you go to RAM connection, it's going to go ahead and redesign all of your connections using the template that you had assigned earlier. Okay, so you should be able to make changes to section properties and so forth, come back in. Just important to note for truss connections, if you're now violating those rules where a tubular truss connection is appropriate, of course, then you're going to want to reassign or redesign that connection with a template that would be compatible with that particular joint. So if I save this model, exited it out, and came back in, all these connections would still be assigned. Now, it is important to note that you can incorporate your RAM connection results into your report in the STAAD post processor. You can also print out or export your DXF view of each of your designed connections, if that's going to give you a head start on your detailing or drawing creation process. Now, at this point, this concludes our presentation for our model today. Now, the last thing I want to do, besides thanking you for coming to today's session, is go ahead and remind you that there is some related content available in the widget, okay? And let's go over a few of those things. Now, the first thing I'm going to do is let's go ahead and I'm going to access a few of these. The first thing I'm going to do is encourage everybody to be familiar and to visit regularly Bentley communities. In specific, we have the RAM, STAAD, and ADINA area. Now, within the RAM, STAAD, and ADINA wiki, we do have learning resources, and these are available for each of the products. And I went ahead and put a link to the STAAD learning resources for this particular session. And if we were to drill on down to the steel learning resources, what you would see is that we have provided you access and links to access all of our on-demand training on steel design within STAAD.Pro that's available for free on YouTube. Okay, so you can go ahead and click on any of these options. You can see here we have some playlists for several different US and international codes on steel design, and including on that we have designing steel connections. So we have two different playlists on designing steel connections within STAAD.Pro. So today what we focus on specifically were those truss connections, but there are a lot of other connection types available, and here we'll walk you through several of those that are available here. We also have the option to use connection tags, which may help for integration. So I'm going to go ahead and encourage you to kind of look in this. Again, it's in the RAM and STAAD wiki, RAM and STAAD learning resources. If you want more information on RAM connection, we also have a complete wiki that will show you several of the key features. We're going to show you what geometry we support, what international codes we support, what types of joint configurations we can handle, okay? And in addition to that, we're going to go ahead and tell you what members are acceptable for each type of connection. So each type of connection might have its own rules, and they're code compliant about what can be used for the column section, the beam section, or the brace section. I know sometimes that could be a little bit confusing when using this product. So we went ahead and tried to explain which codes are they available for, which sections do we support, are there any like slope or skew angles that would be allowed for that type of connection. So here we've tried to break it all down, and that's available in the RAM connection key features. That's also in your related content. The last thing I want to point you to is the Bentley Structural YouTube channel. And I'm going to go ahead and encourage you to subscribe to this channel, because when you subscribe to a channel within YouTube, of course, you're going to be notified when new videos are added, and we add videos regularly to this channel. We will have full lists for training. So we try to organize all of our training content into their particular workflow. They are organized by product. Here you can see if I'm learning about STAAD.Pro, I have a vast number of playlists for different workflows. This is all official training material. Okay. I also have links to past webinars that are available here, and then we also have some tips and tricks. So I'm going to go ahead and encourage you to be active on Bentley communities, be active on our YouTube channel, to again just get all these resources that are available to you. Okay, at this point, this concludes our session for today. I want to thank you all for coming to today's session on designing truss connections within STAAD.Pro using RAM connection. I am planning on conducting another Coffee Corner session in August. I believe my topic will be using design review for a cloud-based workflow with the iTwin services. Definitely look out for that. That should be available for registration in your email come August. Also with your in-app messaging. Okay, that's the little messaging that appears at the bottom right-hand corner of your screen when you launch STAAD.Pro. So I'm definitely going to encourage you to do that, to look for our next one. And then in addition to that, I'm going to go ahead and ask you all to complete the survey that goes along with today's session. Now at this point, I want to thank you all for coming to today's session. Hopefully you found value in this. Hopefully this will give you a good start, if you have these types of structures, to be able to use RAM connection within STAAD.Pro to successfully assign truss style connections to truss joints. At this point, thank you all for coming, and I hope you have a wonderful afternoon.